our discussion from here. So now try to see the another type of disturbance. So when you disturb the spring, right, very soft, easily it can propagate that energy, right? See here how they are. So that particles are forwarding along the horizontal direction, and energy also transferred by them in the horizontal direction. So these type of waves are called here longitudinal waves or mechanical waves. Longitudinal waves or mechanical waves. So why I'm using mechanical waves? So without the medium, they cannot propagate. Without the medium, they cannot be propagated here. So here like this. Then here simply we need to understand about this. So here in this you can see the particles at somewhere located large in number in the smaller region. If you go some same area, what happened? The density of particles decreasing. The density of particle decreasing. So more densive region, particles are more densive. That is called here compression. What we can call it as compression. What about this one? Rarefaction. So compressions and rarefactions are observed in the longitudinal waves. Longitudinal wave is nothing if the particles are vibrating horizontal to the propagating direction or propagation of energy. If that particles vibration are perpendicular to the wave propagation direction, then it is called as transversal waves. So two types of waves I shown. So here we are able to understand here that wavelength, wave velocity, everything is calculated. So here frequencies we need to understand, wavelength we need to understand in this type of wave also. So nothing that successive compressions we need to find out or successive rarefactions we need to find out. If you are providing the energy constantly, what happens? The disturbance always remains uniform. Then that distance between compressions and rarefactions will be taken as wavelength, denoted by the letter lambda symbol, right? Lambda symbol. So this is longitudinal waves. Sound waves are longitudinal waves. Sound waves are longitudinal waves. So that type of wave understood. Then one more type of wave is there. One more type of wave is there. So here that type of wave is produced by a charged particle. What? Charged particle. So when a charged particle is vibrating, that can create a disturbance. So the disturbance is created by that vibrating charged particle. So that disturbance is having both varying or vibrating magnetic and electric field around it. Electric and magnetic field, both are there. So that electric field and magnetic field are present around the charged particles. So that can be forwarded in its surrounding. Then here, this electric field and magnetic field both are perpendicular to each other. Electric field and both magnetic field are perpendicular to each other, as well as they are perpendicular to wave direction, wave propagating direction or energy propagating direction, right? So electric field is perpendicular to the magnetic field and it is also perpendicular to the wave propagating direction. Magnetic field is perpendicular to the electric field and also it is perpendicular to the wave propagating direction. So what is an electromagnetic wave means? Simply that a wave which consists of varying electric field and magnetic field, both are perpendicular to each other and as well as perpendicular to the wave or energy propagating direction. So which is given as example for electromagnetic wave? So simply we can give example for the electromagnetic wave is light wave. According to Newton, both natures are given for the light, that is particle nature isolates wave nature. So particle nature is proposed by Newton. Wave nature is proposed, given by or proposed by Huygens. So both are given. Then what actually light wave? So it has both particle and wave nature. Particle and wave nature. So it behaves as electromagnetic wave. That means it can create electric field and a magnetic field in its surroundings. So that field we can visualize like this, as you see here. So electric field is taken with the red color lines and magnetic field is taken with the blue color lines, and wave propagation direction is given horizontal direction. So to that horizontal direction, this electric field and magnetic field varying perpendicular to the propagating direction. So energy is forwarded. While the energy is forwarding, electric field and magnetic field is varying around that three-dimensionally, around the three-dimensional, right? So that we can visualize like this. See here, varying electric fields along the three axes. So energy is propagating along the x-axis, electric field is vibrating along the y-axis, and magnetic field is vibrating along the z-axis. Now, have you seen the electromagnetic wave clearly? That simple diagram is given in your textbook. I tried to visualize that electromagnetic wave here. Have you visualized that electric field and magnetic field around that vibrating particles? Give me a response. So this is an electromagnetic wave, right? So varying electric field and a magnetic field. Varying electric field and magnetic field. So here you need to learn about the characteristics in this. So here, see, I stopped that wave vibrations. So here I am observing the maximum displacement was given by it, right? And maximum displacement again observed. So these we are taking as crests. These we are taking as troughs. So capital T. Capital T. So simply the distance between these particles, every time you will get that everywhere. So if you join them by using a horizontal line, that always along this line, see that particles cannot go beyond this line drawn perpendicular, or parallel to the propagating direction. See here, always that in between this line, see that, right? So now they are said to be in the same phase difference. The maximum displacement was given by any particle in this wave is same. So amplitude is fixed. Amplitude is fixed. Now here I am trying to take that what here simply I want wavelength. What is wavelength here? What the wavelength here we are taking? Simply that wavelength is the distance between successive crests or successive troughs. Successive crest or successive troughs. So here I am trying to take that crests and troughs here. So where you have see crest, here is there. Here is there. So this gap between them here is called as wavelength, lambda. For any successive crest, lambda, or any successive troughs, lambda. So this is actually wavelength. So do you got an idea what is actually wavelength? Where do you find wavelength? Have you seen them clearly? No response. Are you in the class? Have you got an idea how to measure wavelength? But here wavelength is what? Very, very smaller. Very, very smaller. In the strong electric field and magnetic field or that a simply electromagnetic field called light. Under this only you are able to visualize this all. Directly with your naked eyes, you cannot see. Right? So strong energy source is required, light source. That may be sometimes monochromatic source of light also, single color. If you want to see that, you need to produce spectrum. What is spectrum? Here you got an idea about lambda. What is lambda? Wavelength. So here spectrum is a combination of different wavelengths. Spectrum is a combination of different wavelengths. Right? So we need to have an idea about wavelength. That wavelength is measured in angstrom units. 1 angstrom equal to 10 to the power of minus 10 meters. 10 to the power of minus 10 meters. Or you can measure that in nanometers also. Right? So it is very, very smaller. Very, very smaller. Nano means 10 power minus 9. So 10 power minus 9 meters is equal to 1 nanometer. Very, very smallest length, smallest gap you are measuring. So that is the wavelength. So that wavelengths are available differently for different colors. It is different for different colors. What the colors are existing in your surroundings? They are visually here. VGYOR. Violet, indigo, blue, green, yellow, orange, red. So 7 colors are there in your visible light. They are what? They are available in visible light. What is visible light actually? How do you define visible light? Light is simply defined as electromagnetic wave and which enables us to see. That is the meaning of light. But here I am asking visible light. Visible light is what you can realize by viewing, or which is giving you sensation of vision. That is only visible light, no difference. But particularly you are able to define that visible light based on the lambda. So that colors are here having different wavelengths. It is different for different colors. You are able to see the different colors, yes or no? Are you able to see the different colors? Yes, we are able to see. What the colors you are able to see? That namely here 7 colors, which is example for that 7 colors at a time. Where you can find that 7 colors at a time in your daily life. Naturally. Naturally. Have you seen the 7 colors in the nature?
Sorry, in rainbow.
Yes. In the rainbow, we can find these colors. So, simply, what is rainbow here? Right? Consisting 7 colors. Right? This is here simply. Why it is named as rainbow? Because when you are able to see this rainbow, compulsory you need clouds presence or that clouds giving rain. Without that, you cannot see. Right? Or especially on a humid day, you can see due to presence of moisture in the air. So without water vapor in the air, you cannot find this rainbow. So especially on rainy day, you are able to see in the presence of light only. Again, you need a sunlight. Without that, you cannot find. Right? So it is because of what? Presence of light, isolates moisture. So something phenomenon is going to be take place. That is simply dispersion phenomenon. So we are not discussing the dispersion. Due to something phenomenon, you are able to see the colors. So you need to understand about these colors, how they are able to produce due to change in the wavelength. Due to change in the wavelength. So here, that wavelength is what? Lambda here. Varying wavelengths are there for these 7 colors. So they are what here? Lower wavelength to higher wavelength or higher wavelength to lower wavelength. So this VGYOR is arranged from smaller wavelength to higher wavelength. Red. Higher wavelength. So smaller wavelength to higher wavelength, that colors are arranged in the rainbow, right? So lower wavelength to higher wavelengths, that arrangement of wavelengths consisting different wavelengths, that combination only here said to be spectrum. What is spectrum? Do you got meaning? Can anybody define now spectrum? What is a spectrum? Please define me. Give me the definition of spectrum. Are you hearing me? What is meaning of a spectrum here? Spectrum is nothing different combinations of wavelength. Combinations of wavelength. Or you can take that in terms of frequency also. Combination of different frequencies. Right? So that we are trying to understand in this. Right? So this is idea about the electromagnetic wave. This is about electromagnetic wave. So here we have seen that electromagnetic wave. After this, we are moving into another topic that is called here spectrum and types of spectrum. So wavelength we learned. Wavelength is what? Lambda. That lambda is varying for different colors, not same. So higher wavelength for red color, lower wavelength for violet color, then remaining colors in your rainbow, VGYOR, violet to red, violet to red, violet to red, smaller wavelength to higher wavelength. They are arranged. So this arrangement only here given as spectrum, combination of different wavelengths. So spectrum is an example. Sorry. Rainbow is an example for the spectrum, natural example for the spectrum. Are you able to get this spectrum artificially? Are you able to create these rainbow colors? Using the prism, it is possible. Or a layer of oil on the surface of water. We can see the colors. Right? When the light is reflected from the water surface, on the walls you can see some colors, or through the glass if the light is propagated through them we can see, or on the soap bubbles, surface of soap bubbles you are able to see the colors. These are example for the different colors combination. So color combination is what? That visible clearly separately. By the combination of different colors, you are able to produce a different color. It is not example for the spectrum. For example, on Holy Day, playing with the colors. If you mix the different colors, you are able to get a new color. This is not example for the spectrum. Visualizing the different colors at a time. White light, that is called spectrum. Have you got meaning separately for spectrum? Don't get confusion. Combination of colors is not a spectrum. Visualizing that colors combination, right, at a time, visualizing them is called as spectrum. Are you in confusion? Am I giving you any confusion or clear? Are you following me? Now I am in confusion, right? Thank you. So simply we got meaning for the spectrum, right? So here simply spectrum is due to the combination of different wavelengths or frequencies. Do you have any relation here between wavelength and frequency? Lambda indicating the wavelength and frequency is simply number of vibrations per second. Simply I have given the definitions. Wavelength is defined as the length between the two successive crests or troughs or compressions or rarefactions, or simply the distance between the particles which are vibrating in the same phase difference. That is given as wavelength here. Then how many times it can vibrate from its mean positions to the wave propagating direction, right? Number of times it is able to produce vibrations. That number of vibrations given by the vibrating particle in a second called frequency, right? You have one more T, time period. What is time period here? Simply what the time taken by the particle to produce one oscillation or one vibration, right? Suppose here the particle is started to vibrate from mean position. It goes to the maximum displacement called amplitude. From maximum displacement, from one side to the another side of mean position, it reaches and go back to the same place. So this is called one vibration or one oscillation. So here to complete this one vibration, what the time taken by this is called time period. So time period is defined as simply reciprocal of the frequency. Time period is defined as reciprocal of the frequency. 1 by nu is given as time period, because here in a second you are able to produce number of vibrations. That number of vibrations produced in the second, so you are unable to find the particular time period in a one vibration, right? So what the time taken to complete one vibration, it is very difficult to find out. So that's why easy solution is given by taking the reciprocal of what frequency is given as time period. So here simply look at here, frequency is equal to what? Number of vibrations per second, right? So here reciprocal of nu is taken as in a second number of vibrations produced, that you are dividing. So you are able to calculate for one vibration, right? So that is only here given as time period here, capital T. So by knowing this, you are able to give the relation between lambda and frequency. Lambda depends on the frequency, or frequency depends on the wavelength. How's that? See here. See here. Suppose I am taking wave propagating direction like this. If you disturb the thread, rope, if you disturb the thread or rope, what happens here? That starts vibrating like this. Is it? If you fasten your vibrations, number of times you are giving that disturbance, what happens? That maybe gives you the vibration like this. So what is the difference here? Type of wave is same. Type of wave is same, but that disturbance given by the particle here is not same. That here it is going for maximum displacement in the second case, minimum displacement in the first case. So with this, what happens? Automatically the wavelength is changed. Here wavelength is more. Here wavelength is less. So black colored wave, highest wavelength is smaller. Red color wave, wavelength is longer. So here that amplitude will decide the wavelength. Amplitude is what? Maximum displacement given by the particle. Here maximum displacement is given, right? So what happens? Automatically that wavelength decreases, right? So in this case, what happened here? You are able to say that number of vibrations may increase or decrease depending on the wavelength. Suppose I am moving my hand from the horizontal position upward and downward as much as possible, right? So here, if I go for maximum displacement, right? Maximum displacement, here what happens? Number of vibrations in a second, I can count, okay, or in a minute. So second is very small time, so you are unable to count. Maximum you can take 1 minute, okay. In a minute, count number of times you can move up and down here, right? So here, move your hand here and there only, like this. Here amplitude is smaller given. In this case, I am counting how many times I am able to move upward to downward to upward, one vibration. So that many times I can count in a minute. So in which case you are able to get more number of vibrations with a small amplitude or maximum amplitude? Smaller amplitude or a greater amplitude? Smaller amplitude will give you number of vibrations more, right? So wavelength is smaller. Wavelength required smaller. So wavelength becomes smaller. Wavelength becomes smaller. Then you are able to get frequencies more, right? So what happens? That energy propagation also increases with increasing it. So wave velocity also increases. So lambda is proportional to V. So here by removing that, you are able to introduce one constant called frequency. So here it is constant. Here simply that nu is a constant called as frequency, number of vibrations produced in the wave called frequency. So here he simply, sorry, wrong written. By removing that proportionality concept, you are able to introduce a new symbol called frequency. V equal to nu lambda. Here V is velocity of the wave. Velocity of the wave. So this is the relation you have in your 9th class sound lesson, right? V equal to nu lambda. So for any wave, you can apply this formula. V equal to nu lambda. V is the wave of velocity, nu is the frequency, lambda is the wavelength. So these are the characteristics are given by any type of wave, right? Then here, by using this, you are able to calculate velocity of electromagnetic wave. So electromagnetic wave is propagating with the wave light. So speed of light in the vacuum is taken as speed of light, so speed of electromagnetic wave, C equal to nu lambda formula, we can take it. For sound, we can apply V equal to nu lambda. For the electromagnetic wave, we can take the formula C equal to nu lambda. C is the velocity of a wave, right? E is equal to 3 into 10 to the power of 8 meter per second. Then what about this lambda and nu? Nu is the frequency, lambda is the wavelength, right? So that we are trying to understand. So this is basic information about this structure of atom. So tomorrow we will discuss about the spectrum, electromagnetic spectrum, types of spectrums like emission spectrum, continuous spectrum, visible spectrum, right? Emission line spectrum, absorption spectrum, like this we have. And what is the energy of the wave? That topics we will discuss in tomorrow's class. Then we will enter into our topic related to the structure of atom from activity number 2. So these are basic concepts related to chapter structure of atom. So now give me your response. How you are able to understood this lesson? That basic concepts are clear, or there any confusion?